When we think about e-waste, we often think about disposal, old devices, obsolete technology, items that no longer serve a purpose. But what if e-waste isn't the end of a product's life cycle, but the beginning of a new supply chain? E-waste recycling has emerged as a powerful domestic source of critical materials that support modern manufacturing, the global energy transition, and long-term resource security. This is the story of how recycled electronics are helping power the future. Every year, millions of electronic devices are retired from homes, businesses, schools, and government facilities. Laptops, servers, phones, batteries, and industrial electronics may no longer be in use, but the materials inside them remain highly valuable. E-waste is not random or unpredictable. It forms a consistent and growing material stream driven by technological advancement. Unlike natural resources that must be extracted once and depleted, electronics already contain refined metals that can be recovered again and again. When recycled properly, e-waste shifts from being a disposal problem to becoming an urban mine, one that exists right where materials are needed most. Modern electronics contain a dense concentration of critical materials essential to today's economy. Copper recovered from wiring, motors, and circuit boards is vital for electrical systems, vehicles, and infrastructure. Aluminum from device housings and heat sinks supports lightweight manufacturing and energy efficiency. Gold and other precious metals from connectors and microcomponents enable high-reliability electronics. Lithium-ion batteries provide cobalt, while rare earth elements are found in magnets, displays, and advanced components. Recovering these materials from e-waste requires far less energy than mining and delivers materials that perform just as reliably in new products. Many of the world's critical materials are sourced from a limited number of regions. This concentration creates vulnerability, whether from geopolitical conflict, trade restrictions, environmental challenges, or labor concerns. By recovering materials domestically through e-waste recycling, supply chains become more resilient. Manufacturers gain access to local material streams, transportation distances shrink, and dependence on overseas extraction is reduced. E-waste recycling doesn't replace mining entirely, but it significantly offsets demand, stabilizes supply, and strengthens national resource independence in an increasingly uncertain global market. Not all recycling operations are the same. Licensed recyclers play a critical role in transforming e-waste into a trusted supply chain. Through documented processes and controlled handling, licensed recyclers ensure materials are tracked from collection through final recovery. This traceability allows manufacturers to verify material origin, processing methods, and environmental responsibility. Transparency matters, especially for regulated industries, sustainability reporting, and long-term procurement planning. Licensed recyclers provide confidence that recovered materials are handled responsibly and can safely re-enter industrial supply chains. Manufacturers across electronics, automotive, energy, and infrastructure sectors are increasingly turning to recycled materials, not as a symbolic gesture, but as a strategic decision. Recycled metals reduce exposure to volatile global markets and unpredictable pricing. They support sustainability commitments by lowering carbon footprints and reducing environmental impact. And most importantly, recovered materials meet the same performance standards as virgin materials. As regulations evolve and customer expectations rise, recycled inputs help manufacturers remain competitive, compliant, and resilient in a rapidly changing economy. When viewed through a supply chain lens, e-waste recycling becomes more than waste management. It becomes infrastructure. Recycling facilities function as domestic resource hubs, recovering and reintegrating materials directly into manufacturing ecosystems. They support energy transition technologies like electric vehicles, battery storage, and renewable power systems. By keeping materials in circulation longer, recycling extends the life of finite resources and reduces the environmental burden of continuous extraction. This shift transforms recycling into a foundational component of economic and industrial planning. As technology adoption accelerates, so does the volume of recoverable materials entering the waste stream. Every device retired today becomes a resource for tomorrow's innovation. E-waste recycling closes the loop, connecting product use, recovery, and reuse into a continuous system. Licensed recyclers anchor this system with transparency, accountability, and consistency. In the future, material security will depend not only on what we mine, but on what we recover. reuse, and reintegrate. E-waste recycling isn't just about managing yesterday's technology. It's about securing tomorrow's materials, strengthening supply chains, and supporting a more resilient future. If your organization is looking to responsibly recycle electronics and support a sustainable material supply chain, we're here to help. E-waste recycling isn't just recycling, it's resource security.